All right, so here we go. So, factoring trinomials where a is greater than 1. Okay. Tricks. All right. So I hesitate. I don't like teaching tricks, right? Because they don't really make any much mathematical sense. But they're useful. They make some of the stuff that's kind of tricky a little bit easier. All right, so let's pick one that we already know the answer to. Let's go with number 4 from the homework. So number 4 from the homework, if I pull that one back up here real quick, we see that number 4 was originally 5n squared plus 19n plus 12. All right. And so you can see again the challenge here is not so much with the 5. The 5 is pretty easy to kind of like figure out. It's got to be 5n times n. That's easy. But then it's the 12. Well, it could be 3 and 4, 2 and 6, 12 and 1. And then you have to multiply those things by 5 and 1 and then figure out how to add them then to make 19. Kind of tricky. All right. We see though after some some work there or whatever that it's got to be plus 4 and plus 3. So we already know this answer right here. All right. So the real challenge with these problems is that we have this number, this coefficient that shows up in front of the n squared, right? When we were doing problems on the other side of the homework, these were bad, but they weren't the worst because, again, it's just a matter of figuring out, okay, what multiplies to make 9 and adds to make negative 10? What multiplies to make 64 and adds to make 16? All right? So, with this, we have that extra coefficient there, so we not only have to worry about making 5, but we also have to then multiply our other numbers there by that 5 and the 1 there, and then make sure they combine together. So it's just a little bit extra work. But there's a way we can kind of transform this kind of trinomial into the one where it's a equals 1. And it's basically this. You just take that 5 and multiply it to the 12. Okay, so I'm going to rewrite it here so that way it looks like a separate problem. So we'll do 5 times 12. And 5 times 12, well, that's 60. And so we rewrite a new trinomial, okay? And this new trinomial is not equal to this one up here. Okay, it's not equal. Okay, and by the way, this first technique that I'm showing you here is called slide and divide. Okay, it's like the trickiest of the two that I'm showing you. And by trickiest, I don't mean like trickiest hard. It's just like there's not a whole lot of sense, I guess, behind what we're doing, but it does work. So that's why, And I'm sure there's like a good mathematical explanation for it. But anyway, so we take that, and then we look at this, and now we've created a trinomial. Again, this trinomial is not equal to the one before it. Not equal to this. These are not the same trinomial. But what we've done now is we've gotten rid of that 5 out front. And so now we have a kind of like more easy kind of trinomial that we want to factor. So we're going to actually factor this one. Okay, so we need to think of two numbers that multiply to make 60, but add to make 19. So what do we say here, Mary? 15 and 4. You got it. So there they are. Okay. So great, we factored it. But these do not look like these, right? These answers here do not look like these answers here. Right? Not even close. Completely different. So then what are we gonna do here? Well, so this is called slide and divide, right? So here's the slide part. We kind of like slide the 5 back to the 12 there. All right, and now after we've factored here, now is where we do the divide part. And what gets divided are the numbers at the end here. And we're going to, since we slid the 5, we're going to divide by the 5 over here. All right. 15 divided by 5 is what? 3. 4 divided by 5 doesn't simplify or anything. It's going to give us a decimal if we actually do that fraction. So since it doesn't simplify any further, we're going to take the 5 and slide it right out here in front of the n. And through some mathemagic there, we end up with the answer. Slide and divide. Okay?
Does it work on like every single one or not?
Yes, it will work on every single one. Now let me there are some, I gotta think, we'll see. Let me see if do I have my examples? No. Let me get one that I have. There's one thing. So sometimes the fraction will like simplify. Okay, I've got one here. So let's try another one here, just so we can kind of like see this. 4x squared plus 4x plus 1. One time when slide and divide fails is if you didn't factor out the GCF. If there is a GCF, you have to factor out that GCF. So slide and divide fails if you did not slide out or factor out the GCF first. Okay. So if we look here, right, is there a GCF to factor out? Yeah, no, there's nothing in common, so we can go ahead and do the slide and divide. So again, we'll slide the 4 back to multiply by the 1. And so that transforms into x squared plus 4x plus 1. Oops, sorry, 4. Can't do math. There we go. Okay. And so now we'll factor this. So we need two numbers that multiply to make 4, but add to make 4. So Evan? X plus 2, x plus 2. You got it. And then we divide both of those by 4. Okay, now, does 2 divide by 4 evenly? No, but it can simplify, right? Yeah, it simplifies to 1/2. So we need, and in fact, we have to simplify it. So simplify. The denominators that we're left with, we slide those back in front of the x's for their binomials, and we end up with then 2x plus 1 times 2x plus 1.
And that works.
And yeah, I'll show you here. I mean, it does in fact work. If you look here, 2x times 2x, 4x squared. 2x times the 1 plus another 2x times the 1. And then 1 times 1. So it does equal 4x squared plus 4x plus 1. Okay, that's slide and divide. It's a trick. Alright, it's a trick. But it works. I'm not really sure why it works, but it works. Okay. Mathematically, it really doesn't give us much basis. So what inevitably ends up happening with these tricks is I show them to you, then you get to your next teacher and you get to this point, and you're like, Miss Whitmire taught us this trick. I can't really remember how to do it, but it was kind of nice. And then you learn your other teacher's way of doing things, and then you forget completely about slide and divide. And that's the problem with tricks, is that they're tricks. You like learn them, they're little tricks, they don't really like have much sense, and so you forget them just as easily as you learn them. Okay? That's the problem. So remember, we can always fall back on the fact that, we need to multiply, we need to have, just basically we break it down and say, okay, I need two numbers that multiply to make 4x, So in this case, I'm going to say 2x and 2x because I know the answer. I need two numbers then that multiply to make 1. Well, it's got to be 1 and 1. And so sure enough, that will multiply to make that. I mean, you can still do it that way, but slide and divide is a nice way to do it because it's quick, easy, and tricky. All right. Anyone want to see another slide and divide? Are we all good with that one? Are we all good with it? You want to see another one? No? Yes? No? Yes? No? We're good? All right, Maria, you got it? You're good? You want to see another? Let's see another one. Let's see another one. One more. Uno más.
Wait, how long is like this whole side?
You could have used slide and divide on those. Yep. Exactly. All right, let's look at. All right, let's try this one. Ooh, this one's. Okay, yeah. Let's try 6a squared plus 25a plus 25. All right, so we'll try this one here too. And then I'll give you guys one to try. And then I'll show you the other method that we've got, the other method. And again, they're related. It's related. Okay. So again, slide the 6 back to the 25 there. Slide. All right, so you get a squared plus 25a plus, 6 times 25 is 150. All right, so you can see why this technique is not the best. We're going to end up with some big numbers sometimes, and so we have to think of two numbers that multiply to make 150, but then add to make 25. So Evan's got it, though. 15 and 10. Sounds good to me. Yeah, looks good. So then that would factor to a plus 10, a plus 15, and then we do the divide part. So divide both by the 6. Now again, neither of those divide evenly by 6, but both those fractions simplify, right? And so we get 5 and 3, and we get 5 and 2. Yes, okay. And so then we slide out those denominators there, and so we end up with this 6a squared plus 25a plus 25. We end up with that being equal to 3a plus 5 times 2a plus 5. Okay. And there it is factored. Okay. So that's that. So here, you guys try one. You can do it whichever way you desire. Try 6y squared plus 5y minus 6. 6y squared minus 5y plus 6. Oh, sorry, 6y squared plus 5y minus 6. Got my signs mixed up there. Alright, so Tanner, what'd you come up with here?
5y plus 2.
You said 5y plus 2?
And 2y minus 3.
Okay, so let's see here, use...
No, 3. That's 3y.
3y plus 2. Okay, can't read your own handwriting, huh? 3y plus 2. 2y minus 3. Okay, what do you think about that? Is that going to work here? Let's see here. 2 times negative 3 is negative 6. 2 times 2 is 4y. Negative 3 times 3 is negative 9y. I think our signs are mixed up here.
I had it opposite. Like, I had 3y minus 2.
Yeah, it's close, but I think our signs are backwards. It should be 3y minus 2. 2y plus 3 there. That will result in the correct thing. Okay, so yeah. So I'm guessing when you did the original factoring, I think you just messed with the signs with that one. But yeah, this is what it should be. This is what it should be. Okay. So there it is. Easy peasy. All right. I'll show you another way here. It's similar to slide and divide. I think it has like a little bit more like relation to what we've done, kind of stuff we've done before. All right, so let me show you this one. I don't have a cool name for this one. It doesn't rhyme, so you'll probably like forget this one even more quickly. But I'm going to show it to you anyway here. All right. This one involves, so again, you know, a problem like this with a not equal to 1. Okay. What we're going to do here is start off the same way. We're going to do 5 times 9. So that gives us, 45. Okay. And similarly to what we did before, we're going to think of 2 numbers that multiply to make 45. Okay, so we're not going to focus on the 9 here and try and multiply to make 9. We're going to focus on multiply 2 numbers that multiply to 45 but add to make negative 18. Negative 15 and negative 3. So in this case, right, we have negative 15 and negative 3. These 2 numbers, all right, multiply to make the 45, but also add to make negative 18. Notice we didn't change our trinomial at all here. And in fact, what we're going to do now is going to use those 2 numbers that we just identified and break up this middle term. Like that. All right. So are these two expressions equivalent? Are they saying the same thing? Yes, they are. Okay, negative 15x minus 3x, that's still negative 18. So these are the exact same statements. But you might be wondering, so why did we break this up like this? Well, we can factor here by grouping. Okay, remember that was a technique that we looked at, I think, 2 days ago, factoring it by grouping. If we look at these first 2 terms here, what can we factor out? Not just a 5x. Yeah, if we factor out a 5x here, we're left with what? X minus 3. And then here I have a negative 3x and a positive 9. What can I factor out of that? Yeah, you can factor a 3 out. I'm going to suggest factoring a negative 3 out, and I'll show you why here in a second. So factor out a negative 3, we're left with x. Well, factor a negative 3 out of 9, it becomes x minus 3. And then what do you notice? Yeah, we end up with a common binomial there that can also then be factored out. So now we can factor out this x minus 3 from each thing. And so if I factor x minus 3 out of this, what's left? 5x, and then the minus 3 is left from there, and there's our answer. That is equal to how you factor that one. Okay. So that one involves still some trickeration. We have no idea really why that works. It does work. Or well, not that we have no idea how it works, but there's a lot more going on behind the scenes, I think, than what we kind of realize. All right, but it does work. Okay, it does work. And it's similar to slide and divide. We still kind of do the slide part. We don't end up doing the divide part. Well, not the same way. Excuse me. Let's try another one. All right, let's get crazy and try another one here. Let's do... Ooh. Did we do that one already? No, we didn't. Okay, here we go. This is going to be a fun one. All right, 6x squared plus 7x minus 49. Oof. It's going to be a big number. Okay, Hunter's getting the calculator out. So again, the idea is we want to do 6 times negative 49. So that's going to be 294, you said? Okay. Yep, I buy that. I believe it. And now we have the very simple task of trying to figure out what are 2 numbers that multiply to make negative 294, but add to make 7.
21 and negative 14.
Sorry?
21
21, negative 14, okay. So plus 21x minus 14x minus 49. Now, does anyone wonder what happens if I put negative 14x here and 21x here? What if I flip them around? It's going to end up being the same thing. Yeah, it'll end up being the same thing, okay? Eventually. Maybe your like intermediate work will be slightly different than mine, but you will end up with the same exact answer, okay? And again, by some mathemagic here, right? 6x squared and 21x, if I kind of group those together, what is a common factor between those two things? Yeah, 3x. And we're left with, 2x plus 7. And then from these two terms, what can I factor out? A negative 7. Yep, very good. And we do want it to be a negative 7, so that way we end up with a positive 2x and a positive 7. And there it is. Same two terms there, 2x plus 7. Factor it out. 3x minus 7. Voila. Okay. Minus 50 maybe. Okay, let me just check something here real quick. Okay. So now let's just slightly change this problem. 6x squared, okay, plus 7x. And instead of saying minus 49, let's say minus 50 now. Okay, if you want to write this one down, you can, or if not, you can just kind of follow along with it. This one's like just for kind of like, I don't want to say like for fun, because everyone would probably eye roll if I said this for fun, but just to kind of see what happens here. So we try and factor this one. Follow the same path, so 6 times negative 50, now that's negative 300. I think that's the easiest one. Okay. So we want to try and think of two numbers that multiply to make negative 300, but add to make 7. So you can kind of try to come up with numbers here. So let's see. Well, there's like negative 30 and positive 10. Not quite. There's positive 30 and negative 10. Not quite. Let's see. There's 15 and 20. Sorry, one of them needs to be negative. There you go. Negative 15 and 20. Yeah, not quite. There's 15 and negative 20. That's still not right. Well, let's see. What else do we have? We have a lot of options. Okay, 3 and 100, but that's way too far off. Even negative 3 and positive 100 is way too far off.
25 and negative 12.
25 and negative 12? Let's see here. So that does multiply. Sorry, that does multiply there to make. But yeah, it wouldn't quite work, would it? Maybe 13. We could do negative 25 and positive 12. Okay. Am I missing any pairs?
Something between 25 and negative 25 and 12 and
Okay. Well, let's see here. Yeah, there's 150 and 2. Okay, that's good. Yep, I'm missing that one. But again, those are like really far apart, so we know they're not going to work. And of course, there's the 300 and the negative 1 and the negative 300 and the positive 1. And again, those are way too far apart. Missing anything else? Let's see here. 2 times 4, 12. Plus 15. 2 times 4. 24. No. Yeah, no. And so we can't find two numbers that add up to this 7. What does that mean? It's not possible. Okay, and that is, in fact, what the case is here. Or at least it's not factorable. Okay, not able to be factored. Okay, the way we've been factoring at least. So yeah, this one doesn't factor. Okay, and in fact, if I were to have each one of you kind of like come up with your own trinomial, just like make one up, you know, using just whatever numbers you pick, the majority of them would not be factorable. We're working with actually a very small population of trinomials that happen to factor. Okay, it's more common for them to not factor than to factor. So we're working with kind of a nice population of them that do factor, so that way, you know, we can actually like do it and see it. Later in future classes, you'll learn how to come up with solutions to that. You'll have, there's like a formula you can use that will help you solve any of these regardless. Sometimes it involves using imaginary numbers to solve it, like square roots of negatives. Those are imaginary numbers. And sometimes it involves using square roots to solve these too. But for our purposes, we're only going to focus on ones that factor to, you know, integer or rational numbers, I should say. So integers, fractions, stuff like that. Okay. So there's that. All right. This next one I want to hit, and this will be the last one here. And I just want to like see how we do with this. So how about like x squared minus 25. Okay, this is a special trinomial. Anyone know what we call this kind of trinomial? It's not a trinomial, I guess, actually. But there's a special name for this. We have two perfect squares, and we're subtracting them. So it's a, you know, I thought you were going to raise your hand. Difference of squares. It's a difference of squares. Okay. It's called a difference of squares. And believe it or not, it does factor. And we can, even though it's not a trinomial, right, there's only two terms here, so technically it's a binomial, but we can make it kind of fit a trinomial by doing x squared plus what number can I put in front of the x here so that it's still equal to this?
1.
So is x squared plus 1x minus 25, is that the same thing as x squared minus 25? Yeah, it's not. We can't put a 1x there. What could we put? A 0. A 0, yes. Okay, we can add 0x. I could add 0x cubed if I wanted to. But we're going to use 0x. Why is that? Well, because now we have a trinomial, and we know how to factor these kind of things, don't we? We need two numbers that multiply to make
5 and
negative 25, and add to make what? 0. So what's that?
5 and negative 5.
Yeah, exactly right. 5 and negative 5. Boom. Okay. Difference of squares. There it is. Just throw a little 0x in the middle there, and that's what you got. Okay. Question on any of that? All right, very good. Then I actually have some kind of like mixed practice that has some of those difference of squares on them for you to try. Yes. Okay. And then I'm going to try and get you some more of those trinomials with